trying to get rid of that for you. All right, and so then diverges means that the limit is infinity or non-existent. So infinity is a limit, it's just not a finite number. So if your limit is infinity or non-existent, then it's going to be considered a divergent sequence. So let's look at a couple of sequences here. And it says we have to find the first four terms. So here's where n is going to represent your number term in that sequence. So we're going to find a sub 1. And so that equals 3 times something minus 2. So whatever n is, in this case 1, we're going to replace this time 1 with n. And so what value do I get here?
1.
That was a tough one, right? So your very first term in the sequence, a sub 1, has a value of 1. Then you're going to find a sub 2. This time we're replacing n with 2. So because n is 2, this time we have 3 times 2 minus 2. What does that give you?
4.
Taxing your brain, right? Then a sub 3.
Which is 7.
Yep, you're going to replace n with 3 this time, and you do get a value of 7. So by this time you should be able to see a pattern because this is an arithmetic sequence. It is increasing by the same amount each time. And so you should be able to hypothesize what a sub 4 is going to be. What is it going to be?
13.
Not 13.
No.
So we do indeed get 10 as a value. So we've found our first 4 values. So you'll have, 1 or 2 problems on your homework that looks like that. Arnold, off your desk, please. And then for the second problem, what have they given you here?
A sub 1.
Which is what?
4.
Which is what?
Which is basically 4.
What's a sub 1 represent? It represents what? What is that? Okay, a sub 1 does not represent n. 1 represents n.
First term.
Thank you, that's what I was looking for, the first term. So this is your first term. So haven't they given you part of the answer?
Yeah.
Then they've given you this part here, this whole part here, and do you see this a sub n minus 1? That immediately tells you that this is recursive. And what recursive means is that it's going to use, or it uses, the previous term. Each time we do a new term, it uses the previous term. So I'm going to use the notation once, and then I'll start to slack off in that notation. For instance, we already found a sub 1, so we're going to find a sub 2. So technically, a sub 2 is equal to, I'm going to take 3, and I'm going to replace, just in that n, I'm going to replace it with a 2. So I have 3 times a sub 2 minus 1, and then overall minus 1. So what does a sub 2 minus 1 equal? A sub 1. So what they're really asking you to do is to find 3 times a sub 1. Isn't a sub 1 the previous term, the term before a sub 2? And then minus 1. So we're going to replace a sub 1 with what value? What's the value of a sub 1? 4. So we're replacing that. So we really get 3 times, whoops, I don't want yellow. 3 times 4 minus 1. What does that equal? Yep, that's 11. So that's our second term. So look again what happened. And we're not going to write this. It gets a little complicated if you continue to write it that way. But essentially, this a sub 2 minus 1 is equal to a sub 1, the previous term. And so the previous term was 4. We got that from up here. And so now we have 11. So then when you go to find a sub 3, we're going to do 3 times something minus 1. This is going to be a sub n minus 1. Well, n is 3. 3 minus 1 is 2. What is the value of a sub 2? 11. So we're going to take that 11. We're going to put it in here. So that previous, you can't see that, can you? Let's pick a prettier color. So that 11 comes in here and gets substituted in. So what's 3 times 11 minus 1? 32. So a sub 3 is 32. Then we're going to find a sub 4. That's our last one. So I've got 3 times something minus 1. What's going to go in that spot? The previous term, 32. So that 32 goes in here. What's 32 times 3? 96 minus 1? 95. So recursive looks a little bit more complicated, but it really isn't that complicated. So instead of substituting in the value for n each time like we did in part A, you're just taking the previous term and substituting that in each time. So practice that. Any issues or concerns with that? Okay, so then let's look at convergent versus divergent, and I don't mean the movie. And here's where your calculator is going to become important. So as we look at this sequence here, see if I can get my marker brought up here. There we go. So as you look at the sequence here, we've got 1 over 1, 1 over 2, 1 over 3, and then the sequence continues, and then they kindly give us this 1 over n. If they don't give that to you, you probably should try to find it if possible. And so we are going to find the limits as n approaches infinity of 1 over n. Well, what's going to happen as I replace n with a bigger and bigger value? Because as n approaches infinity, I want to see what happens as it gets bigger and bigger. So what's happening to the value of the number 1/3, 1/4, 1/5, 1/6, 1/7, 1/8? It's getting smaller and smaller and smaller and smaller. What number is it approaching as it gets smaller and smaller? 0. Will it ever become 0? No. Will it ever become negative? No, because remember, the value I'm inputting for n is getting bigger and bigger and bigger, which makes this value here, oops, didn't want that, which makes this value here smaller and smaller and smaller. So that means that my limit is 0. Let's look at what that looks like on the calculator. So go into your calculator, into your y equals, and clear out anything that might be in there. And then I'm going to put in 1 divided by, in our case, x. Oops, that didn't work out. There we go. 1 divided by x. And then hit graph. And then as x is approaching infinity, going to the right here, what's happening to the value of y on the graph? Because the limit is the value of y. So do you see that that is approaching the y-axis, which is 0? So there's our limit. It's converging on the number 0. And so this converges. Whoops, if I can spell correctly today. It converges to 0. Oh, you can't see that. Sorry. Try that. Converges to 0. So let's look at the next one. So the next one, they don't nicely give us the function. But look at what's happening. We've got 2 over 1, 3 over 2, 4 over 3. You definitely see a pattern occurring, don't you? And I can look at this as, well, view what's happening with the denominator versus the numerator. What's happening? 1 to 2, 2 to 3, 3 to 4. Okay, you can look at it that way. Let's not look at them as a total. What's happening from 1 to 2? Adding 1. What's happening from 2 to 3? Adding 1. What's happening from 3 to 4? Adding 1. So couldn't I view this down here as n? Because isn't the 2 over 1 my first number in the sequence? So here we go, n is 1. And then what are we going to name the numerator? Get my point in the right spot. In relation to n, what's happening? N plus 1. So we've got n plus 1 up here. So we're going to find the limits as n approaches infinity of n plus 1 over n. So before I show you the math involved with this, let's look at the value of the fraction and see what's happening with that. So 2 over 1 is 2. 3 over 2 is 1 and 1/2. 4 over 3 is 1 and 1/3. The next one would be what over what? 5 over 4, right? So that would be what, 1 and 1/4, and we'll do one more. The next one would be what? 6 over 5. And that value would be 1 and 1/5. What do you see here occurring? What's always the same, with the exception of the first number, what's always the same? We have a 1 in the mixed number. What's happening to the fractional part of the mixed number? 1/2, 1/3, 1/4, 1/5. Isn't that the same sequence as what was happening over here? So we can actually look at these differently. So it's getting closer and closer and closer to what number? Not 0. The fractional part is, but as the little fractional part gets smaller and smaller and smaller, it's getting closer and closer, not to 0 this time, but to, because it's 1 and 1/5, 1 and 1/6, 1 and 1/7, 1 and 1/8. Pretty soon it's going to be 1 and 1/millionth. Isn't that pretty close to 1? So be careful that although the fractional part is approaching 0, we have a 1 in there. And so we can actually tear this apart. If you have a monomial in the denominator, you can divide each of the terms in the numerator by that monomial. So let's look at what that looks like for our limit. And so that would be n over n plus 1 over n. What does n over n equal? What's n over n equal? There's where the 1 comes from. And then the limit of n over n, which is 1, the limit of 1, the limit of any number, I'm waiting for my cursor to pop up here. Told you, things are slow today. The limit of any number is always that number. So the limit of a constant is that number. So if this had turned out to be 5, the limit of that would have been 5. If this had turned out to be 8, the limit of that would be 8. The limit of 1 over n is what? What did we say the limit of 1 over n was over here? 0. So plus 0, what's 1 plus 0? 1. Isn't that what we said the limit was? Let's look at the graph. So let's go over here. Let's change our y equals, clear that out, and we're going to put in parentheses x plus 1 divided by x. And we expect, and the limit is actually a horizontal asymptote. So we expect this to be approaching a y equals 1 line as x approaches infinity. So as x is getting bigger and bigger and bigger, do you see that there's a horizontal asymptote right through here at y equals 1? So as x approaches positive infinity, this value for y is approaching 1. So you can see that limit on the graph. We don't care about what's happening as we go to negative infinity, although it is the same, isn't it? We'll talk about right and left-hand limits later. Right now, all we care about is what's happening as we approach positive infinity. And so, going back to here, is this convergent or divergent?
Converge.
It has an actual limit of a number, and so it converges to 1. So let's look at C. So again, they did not give us a function, and we're going to look at n up here. So when n is 1, n is 2, n is 3, n is 4. So what is happening to n?
Plus 2, increasing by 2.
Yeah, so to go from 1 to 2, we had to have multiplied by 2 or added 1. To go from 2 to 4, we multiplied by 2. To go from 3 to 6, we multiplied by 2. And to go from 4 to 8, we multiplied by 2. So what does the function look like? 2n. So we're going to find the limits as n approaches infinity of 2n. Now think about what the graph of 2n is. Y equals 2x. What's the graph of y equals 2x? Is it linear? Is it curved? What is it? Y equals 2x. Isn't that y equals mx plus b? The b is 0. Isn't that linear? It's a straight line. And so if you go over here and plug in 2x and graph it, you're looking at a straight line. So as x approaches infinity this way, what's happening to the value of y? It's approaching what? Infinity. Y is getting bigger and bigger and bigger as x gets bigger and bigger and bigger. And if you think about the sequence itself right here, as x gets bigger and bigger and we plug in 4, 5, 6, what happens when I plug in 100? We get 200. What happens when I plug in 1,000? 2,000. So as x gets bigger and bigger and bigger, y, the value for the function, is getting bigger and bigger and bigger. So we have a limit of infinity. It doesn't actually approach a number. So it's not a finite limit. So does this converge or diverge? Yeah, so it diverges. And it does not diverge to a number. It just diverges. Then the last one I find is interesting. There's really not, as you look at this, there's really not a function you can write for this, but there's a definite pattern that you can see. Wouldn't you agree? What pattern do you see? -1, +1, -1, +1, -1. So this is a pattern that is considered oscillating. This sequence oscillates, love that word, forever. Since it oscillates forever, there is no limit. The limit does not exist. It is non-existent. So what would you say? Is it convergent or divergent?
Divergent.
So it diverges. When the limit does not exist, it diverges. Or if the limit is infinity, it diverges. Okay, so let's look at E. And now they're actually giving you a fractional function. So let's talk about fractions. If I were to graph this on my calculator, we're going to have vertical asymptotes and possibly horizontal asymptotes. So we're going to review our horizontal asymptote rules from first quarter. Because remember, it's the horizontal asymptote that creates the limit. It really does. And so, if I were to find the limits as n approaches infinity of 3n over n plus 1. I want to look at the degree of the numerator and compare it to the degree of the denominator. Do you remember doing that? To find the degree of a polynomial, you find the degree of each separate term, and the term that carries the highest degree is the degree of that polynomial. So what is the degree of 3n? What's the exponent of n? 1. So the degree of 3n is 1. What's the degree of n plus 1? Yeah, because the degree of n is what? 1. What's the degree of the 1? This one here. If I can get my Pearson, but what's the degree of the constant number 1? The degree of any constant is 0. And so the one with the largest degree is the n, and so it carries the degree of the polynomial. So both the numerator and the denominator have the same degree. So when the degree of the numerator is exactly equal to the degree of the denominator, and if you want to, for your note purposes, write in there degree numerator equals degree denominator, if I can talk, because you might forget why we did that, then the limit is equal to the ratio of the leading coefficients. Bless you. So what is the coefficient of the leading term in the numerator? 3. And it doesn't matter what order the terms are in. It's the term that has the highest degree that's considered the leading coefficient. And so what is the coefficient of the n here? 1. And so the limit is actually 3, because there is a horizontal asymptote of y equals 3. Look at the graph. And go over here, clear it out, and we're going to put in 3x divided by parentheses x plus 1 end parentheses, and then hit graph. So you should see a horizontal asymptote right here going through y equals 3, correct? And so as x approaches positive infinity, what is the graph approaching for the y value? 3. It's getting closer and closer to 3. It won't ever cross it, but it's going to get closer and closer to 3. So, convergent or divergent? Convergent. So it converges to 3. All right, let's look at f. So what is the coefficient, or I'm sorry, what is the degree of the numerator? 2. What is the degree of the denominator? 3. So that means that the numerator is less than the denominator. When the numerator is less than the denominator, the limit is equal to 0. And here's how I remember that. Think of the one that we just did, the very first one, 1 over n. Isn't the degree of the numerator in 1 over n 0, and the degree of n is 1? Isn't 0 less than 1? And wasn't the limit of 1 over n 0? So it can kind of help you remember these rules by thinking of that one simple 1 over n. So your limit 0. Good gracious, we'll finish this tomorrow. Sorry, your class got less time than everybody else. You ought to be able to do most of, well, half of 9th grade. Started anyway. What's not a breakfast food? Nasty. Oh, they could, chocolate cake would be a great breakfast food. Nice.
Yeah. My dad's birthday was yesterday, so he brought some cake. But I can't eat. Guess what I had today?